All right, hey everybody, welcome to Real Time with Redpanda. This is a show about real-time streaming that we are streaming in real time. Thanks for joining us today. I'm Alex Debrie, I'm our host. This is going to be episode 6 of Real Time with Redpanda, and I'm excited because we've got two great guests on today. I'm going to pull in our first guest, Alex G, founder and CEO of Redpanda, as well as our second guest, Martin, who's a new member of the Redpanda team and has some interesting stuff for us to share today. So thank you both for joining us today. What I want to talk about is this exciting news that got announced last week where Redpanda pulled in this really cool open source project, got the founders to join the team. So maybe Alex G, if you want to tell us about this acquisition, about Kowl, and get us started that way.
Yeah, thanks for hosting, Alex D. So I guess from the beginning, Redpanda has really focused on the developer experience. We created entire product lines just to make the developers' lives easy. And to me, being a practitioner with sort of existing tools, it really felt like distributed system whack-a-mole, because you just had to, when you're to run something, let's say you download it from like an Apache project or a website, to get it run to run this thing in production, you have to perform like 1,000 steps. And the argument for automating a bunch of this was that if you can describe it in English, then you should be able to write code to get these things automated. And so when we actually built Redpanda, almost around the same time, we started co-designing this command line utility called RPK. And so, even though Redpanda is a single C++ binary and you can run it, we focus super heavily on how is the developer going to interact with the system, right? Like, what do they need to know about memory reservations, about locking the memory, about kernel tuning. And so RPK later developed it into its own product line, where it sort of, we embed this intelligence of how to tune computers, how to tune the kernel. Even it has an even embedded database, so that if you run on AWS, it's like, hey, you're running on an i3EN instance. These are the best IOPS settings because we've benchmarked it with whatever, let's say 10,000 computers. And we know that for these categories of machines, if you don't run a perf tuner, these are the best settings for that machine. And by the way, on Google, you should disable this kernel setting, because the firmware lies to the NVMe SSD controller so that most applications in Google run safely, right? And so it became really a product around running Redpanda, right? And it was everything from tuning the kernel to tuning the network queue for multi-queue networking. And then we sort of continued that. And after we built that, we built the Kubernetes operators. How do you do running upgrades, right? Like, why isn't it just, kubectl upgrade this particular container? It should be super easy. And what I felt was missing was really the last mile. And when Martin and I started chatting, I really felt that he was kind of like Indiana Jones coming into this puzzle where, like, you have this keystone or this talisman, and like you plug it into a rock garden or a rock wall, and then like you twist it right, and this whole universe opens up. It's kind of like walking into a Jurassic Park closet. That's really what Kowl is for us. It's sort of the last mile of the developer experience. And I think that with Redpanda, we focus so much on performance and correctness and equally as much as the developer experience, but we really were missing this time travel debugger, this UI that allowed people to introspect and frankly reduce the time that it took them to diagnose a problem in production with their streams. So I don't want to spoil that. And super excited to be joined by Martin Schneppenheim here in the stream. So Martin, welcome. Excited to have you as part of the team.
Thank you. Thanks for having me. Hey, everyone.
So why don't you tell us, I guess, how did you get started with streaming and with Kowl? It's such a cool story.
Okay, I think to explain that, I will probably need to tell you a little bit about my experience from my previous job. So I worked at a platform team at a pretty big e-commerce shop in Germany, and Kafka was used as like the central system where hundreds of sources were connected to consume data from or produce data to. And with my team, I was in charge of managing all these Apache Kafka clusters. We had like tens of them. And we operated all of them on Kubernetes, and I think it's fair to say that it is anything but trivial to operate these Apache Kafka clusters. You have to monitor them. You have to ensure that a single service cannot take them down by consuming all the available resources. You have to ensure that the data is balanced. And on top of that, you still have to maintain another distributed system, which is Zookeeper, which no one really likes, I believe. And yeah, I try to make my life a little bit easier, my little ops life a little bit easier by writing a Prometheus exporter. And the reason for that was, for instance, when you want to export Prometheus metrics from Apache Kafka, you can only do that indirectly via the JMX protocol. So there's the JMX porter thingy. And we had to export like many metrics. We had tens of thousands of partitions, and we wanted to have some metrics which are per partition, like the throughput, like the high watermarks, consumer group legs, and frankly, that was just too much data for the JMX protocol, I'd say. So the responses took like minutes, and I tried almost everything. So even running it as an agent within a sidecar. So I had the problem with that, and I decided to write my own tool for that. And that tool would gather all that data via the Kafka API, which is just way faster. So that improved the monitoring.
Sorry, not to interrupt you. I want to get everyone and show you. Just Martin was nice enough to share sort of the earliest sketches of Kowl, and this is what we have here, the origins of Kowl on the back of this napkin here. So yeah, keep telling us about Kowl and what you're building, what you want to show, things like that.
Yeah, so with the Prometheus exporter, I only improved the monitoring aspect a little bit. So afterwards, when I was tasked to write my own service which consumes data from Kafka, I had no idea where this data was in Kafka. Like, I only knew it is somewhere in Kafka, and my colleagues would usually ask other colleagues to figure out into what topics this data would be produced, or they would write a little program which would print data to the command line. So that was really a challenge for me and the productivity killer when I developed these services, because I had no easy way to inspect what data is available inside of our Kafka topics. And the second problem I had when I wrote that service is it was running, but it failed like shortly after, and I had no idea why. So later on, it turned out it was just a malform.json message, which someone sent manually for some reasons. So that was an accident, but it took me like kind of some time to figure out what was going on there. And I was so upset with that I decided to write my own tool again for that. And that was the Kowl. So that was the beginning of that. That was in 2018. And I didn't want to write it on my own because I knew it would be a lot of work. So I approached a friend, which is Moritz. I pitched the idea to him, and we just kicked it off like 1 week later.
But, I think just to comment on that, still actually, while I think getting it started and deploying, I guess if you draw a complexity curve, to me, like existing solutions would be on the far right for experts by experts, where you have things like, Zookeeper and other systems that to manage, and a schema registry and a separate HTTP proxy and JMX. And right, like it's actually really challenging to productionize. It might be easy to get started, air code's easy to get started, but really it's for experts by experts to run in production. And what Redpanda did was really move the needle probably towards the center of a complexity curve. And I think what Kowl does is just keeps pushing the envelope towards like, how do we open this up to more developers? And message introspection is basically something that everyone needs to do at some point. I mean, we do it for our cloud. We actually started using Kowl on our own cloud product just to figure out, it's like, sometimes you don't know why something fails, and you just need to introspect. And I think what Martin is about to show is like, how does this actually integrate into the entire the schema registry, into ACLs, into, it's like, Martin, I don't know if you wanna start with the demo, but like show us like what is the value to me on like why is message introspection so critical? And then basically once you start doing that, you need to understand, ACLs and the connector framework and a bunch of other things. So I'd be curious, as you keep telling us the story, when you show us more of the product, what are the things that a developer needs to understand to debug something in production?
Yeah, sure. So it's exactly as you said. I wanted to make it as easy as possible for developers, which is also one of the reasons why we wanted to have it as a web app, so that there's just a platform team which can make it available to everyone. You just have to enter like the URL and you are ready to go, so that you don't need to set up and fiddle with the connect configuration and so on. Okay, so that is the topic list, which would list all the available Kafka topics. And if you just want to figure out what's in there, you can do that as easy as this. So you have a JSON viewer, and the format is automatically recognized. It does not matter if it's JSON serialized, Avro, protobuf, with schema registry or without. I think we even have support for message pack. So that is pretty easy. And if you want to find a certain message, like for instance, you're looking for, I don't know, like we have a lot of entities which have customer type personal. Actually, I can show that here, I think. So as soon as I type the JSON path, we should see it here in that column. So let's say I want to find like all messages where the customer type is business. I could do that as easy as that. What this does is this JavaScript code is evaluated in a JavaScript engine which runs on the back end, and every message that is processed will be evaluated against that JavaScript. And if that yields true, that message will be sent from the back end to the front end. If it is false, it will just be skipped and it will continue to consume just forward.
Just to interject, I love this. I remember the last time I was working with Kafka and I wanted to find some sample messages or maybe like debug this particular thing. And it's really stinking hard to do that. Like if you're just trying to pull a particular message out of this topic using like KCAT or something like that. So I think just having this UI and be able to explore that message, putting it back into something readable rather than something else. I think, yeah. Anyway, I love this.
Yeah. So let's give that a try. Okay. It was like super fast because it is kind of efficient in the back end. We can process roughly 20,000 records per core per second. So yeah. As you can see, like only business customer types here.
Alex, yeah, I guess on the architecture, we should just sort of highlight on like the diagram. I was like, what are the pieces of the architecture and where does Kowl fit? So just to give people a mental framework of how does this all fit together, and then we can Martin, we should show. I think the schema register integration is probably one of the coolest things that you guys did. It's just so cool. This is obviously really cool to share with folks. See, okay. This is clearly, as you saw, this was Martin's like napkin. That actually looks like the back of a mail envelope or something. Do you remember what that was, Martin?
Actually, it was a proper notebook, but I did on holidays when I was in Egypt, and I was sitting at the beach and I was talking to Moritz during that time, and I just sketched it there. So, yeah.
So there you go. That's the recipe. If you want to come up with a cool UI, travel to Egypt and have one piece of paper, and it's like we're gonna build the company on this.
I love it. If something's so painful that you're still thinking about it on the beach, that must be a good sign that something needs fixed, right? Yeah.
Totally. So I guess just to give people a framework of how do you think about like Redpanda, where this solves the categories of complexity that we solve, and actually kind of like why is this the missing piece? Sort of the Indiana Jones like talisman thing analogy I get. But so just for those new to Redpanda, Redpanda is it's a drop-in replacement and it's a quorum system. Drop-in replacement for Kafka and it's a quorum system. And so that means that when you write your data, it gets replicated to multiple computers. Redpanda, the process kind of went far into optimizing for the modern hardware in that scales with the numbers. We use a thing called a thread per core architecture. It dynamically adjusts at runtime to the number of threads to the memory given. So like from a programmer, right? Like think about deploying on Kubernetes, right? You just don't know what the number of threads are because that's going to be controlled by your ops, right? So like it's really challenging in that you need on just-in-time information on Kubernetes to be able to influence the configuration of how many IO threads are you going to use for background compaction, or how many threads are you going to use for your networking, or how many threads are you going to use for ISR, movement of replicas. And so Redpanda adapts automatically to the hardware. That was a big operational simplicity. Then, just from a mental perspective, RPK came, and this is effectively our CLI, stands for the Redpanda Keeper. And it does things like, hey, if your hardware, right, like remember that Redpanda doesn't run on category theory, it runs on real computers. And so it tunes, the networking queues, the kernel settings, the page cache. Effectively, this thing has to write data to disk. And so it does all of this. It turns, I guess the way to think about it is RPK takes a computer and makes it effectively an appliance, by and large, right? Like if you give it root permissions and you let it doesn't have to, but it can. And even without these optimizations, Redpanda still performs great. But the last missing piece is like, okay, if you really care about performance, just let RPK tune the computer. And then
I just wanted that'd be huge for me. I remember like picking up Apache projects, whatever they are, and getting them running and they work. And then all of a sudden you're out of file descriptors, or you're just like not tuned for whatever reason. I just think that's like so awesome. That's instance based. Also, I just want to share a blog post that Travis wrote this week, just like comparing ARM to Intel and just some of the cool things that on AWS and some of the things. Redpanda's checking out with that. Like I just love the work that you all are doing to like help optimize and figure that stuff out, of just so I don't have to, right? You've done it, like you're saying, on 10,000 machines. You know how an i3 large or whatever works. I don't have time to do all that. So anyway.
Yeah, and it just also doesn't make any sense. I mean, like we are the experts. So like, why are you doing this?
Yeah.
It's like, so if we wrote this storage engine and we wrote the code and like we can adapt to it and we didn't use the page cut. So like, what could you possibly teach Redpanda that we couldn't figure out? And so the answer is zero. Like no one should be able to tune a machine better than Redpanda can automatically learn. It doesn't make any sense. You should present a list of resources and then just frankly, just forget about it. Like Redpanda needs to blend into the background. It's not that interesting for most people to be an expert in how to run Redpanda. It's just really like kind of side effect. So we took these optimizations and then we built sort of the Kubernetes operator. And what it does is really it's deployment, right? And we have Ansible and like RPM files, and Debian files if you want to install it manually. And, I guess Docker is not, whatever, we have Docker and so on. And so we have all of these deployment models. But what Kubernetes is, it's kind of this Oracle orchestrator. And so on a set of physical computers, it will do things like, hey, make sure that you have, AZ1 and AZ2 and AZ3, and it'll do the right placements of the Redpanda binaries and so on. And it's really kind of like, how do we optimize and then now when you need to upgrade it and deploy it, and 2 episodes ago at Alex D, we talked about how this ties into tiered storage optimization. So it's just like, how many levels deep? It's very deep, the rabbit hole. But to keep moving the conversation along, then what happened next is like, okay, so now people can deploy, they can run this in production, and largely they can connect their tools to Redpanda, and it just roughly works, right? It's kind of like, there should be no hero story. There should be no this like, oh, this painful migration, blah, blah, blah. And so stay tuned for a future episode of this Redpanda where we're going to demo a live migration with 0 downtime from Redpanda to Kafka. That's just upcoming. But long story short, so we have this, and the developer is productive. But remember that the sort of the technical sophistication of the person writing code is different in many dimensions to the person actually operating the cluster. And for a lot of them, and also let's say as a CIO, what do you care about? You care about single sign-on, you care about audit logs, you care about, okay, let's say who has the right access to this data, even if it is on the control plane. And so what Kowl did is it kind of completes the bridge. And what I wanted to highlight here is that now is everything from, like, you can run this on your laptop. And I don't know, Martin, if you were running on your laptop or if you're running against the cluster. Yeah, so exactly. So you can run it on your laptop. You can run it as part of a Kubernetes deployment. You can run it as part of like an FMC or whatever it is. And and this just allows you to manage the control plane, like who has access to my logs? Can I decode these things? Can I do time travel introspection? What Martin showed, that filtering, you can select a time query and say, I had an incident at 9:45 a.m. And so from 9:45 to save to 9:40 to like 10 a.m., I just want to understand this 15 minutes of data. That's usually what happens. And so you can look at the consumer lag, which Martin will show in just a second. I just wanted to give people the mental piece as to like, why does this help the complexity? And then just real quick, in terms of the overall, I should probably get better at this. The overall complexity is, I think that existing tools were somewhere here on the expertise curve. So, and what Redpanda did is really push things here probably more towards the left, right? So this is like novice, and then this is expert. And I think what Kowl does is that it takes this one step farther and pushes the envelope a little bit towards the left, right? Like it makes it easier for a larger audience of people that are not even writing code, people that are just managing the cluster, right? It sort of expands who gets to interact with this real-time data clusters in a way that makes them feel competent, and they actually get their job done, and they spend their time doing useful things rather than babysitting the cluster. So anyways, I just wanted to give people the architectural pieces as to the development from Redpanda with kernel bypass on the file system, to RPK, to Kubernetes, to like the modes of deployment with our cloud. And now it's sort of completing that puzzle. It's really that like Indiana Jones analogy. With that, Martin, if you want to kind of show us the schema registry integration and the consumer lag, which is, to me, one of the coolest things.
Absolutely. Before we do that, we had one question on the demo, so I want to make sure we just get that up there. And it was related to that filtering stuff. You showed that really cool filtering logic. Blue Orca came in and said, hey, if I use this to filter on an ID in a large topic, it uses a lot of CPU. Is there some way I can throttle that so it's not doing that? Or the question got cut off there, but like, is there some way to distribute it so it scales horizontally? I know one thing Alex was just saying is maybe specifying a time range. Can you, like, what would be some good options there?
Yeah, that's a very good question. Currently, it is not possible to throttle it within Kowl. So what I would usually do is to set a limit inside of, if you run it inside of Kubernetes, you could say, hey, my Kowl instance is allowed to use up to, 3 CPUs. And then it will also use these 3 CPUs. So that would be my recommendation for now. But yeah, might be a good feature request. So I think you could put it and file it as a GitHub issue.
Yeah, this is an open source project. I'll drop the link in. So make sure, if you have feature requests, things like that, you have the right people on to get some of that stuff implemented, right? So.
Yeah, and also, actually, I would say that if you want to have a chat with us, join the Slack and tell us why. Because sometimes we need to prioritize like what gets done. And so it would be useful. Yeah, so redpanda.com/Slack. Get some swag and tell us like why. Like, okay, look, I have this problem. I'm trying to filter airplane engines, and like sometimes there's like a terabyte of logs, and I care about this, and it's consuming more CPU that I care about. Like, I need to understand those use cases to make sure that we're building a solution not just for one person but for an entire community.
Yep. Absolutely. And sort of like you're saying with the expertise stuff, right? Like if someone's a novice in this area working with Kowl, they'll move up the expertise ladder. But also the more Redpanda hears about these use cases and figures those things out, the more they can like shift that down in terms of what expertise you need to work effectively with that. So yeah, make sure you join the Slack channel. I'm gonna kick it back to Martin and let him walk through some of the cool stuff here again. So Martin, what else do we have here in Kowl?
Okay, so speaking of consumers, we have a view on a topic where you can list like all the consumer groups that consume that specific topic. In this case, we unfortunately do not have any consumers, but usually all the consumer groups that would consume that topic would appear here. And that is helpful because imagine you are in charge with your team for producing that topic, and you want to figure out who are your stakeholders, who consume that data. And this makes it very easy so that you can, for instance, inform them about, a new property that will be produced or a breaking change or whatever. Then there's the petitions tab, which will give you a rough overview about how many messages you have in each petition, how these messages are distributed across these petitions, what brokers are the latest for each petition. So in this specific case, we only have one broker because it is a local setup with a single Redpanda node. But most of the time, you probably have 3 brokers here, and maybe you're interested into like what broker is currently the leader for my specific partition. There's a configuration tab, which will list you all the topic configurations. Those who are grayed out here are just the default configs. And you can also expand that row to see like what would be the inherited value if I wouldn't have it set at the topic level. Like there can be defaults that come from the broker, but there could also be the defaults that are always set. Then there's the ACL tab. We don't have any equals set up here. And here's a handy documentation tab, which we have not configured yet. But the reason why we added it, or what it is at all, you can link it to a GitHub repository, which contains all the documentations for all your topics. And when there is a file inside of that GitHub repository that matches the Kafka topic name, that markdown file will be rendered as HTML inside of Kowl. And the reason why we built that is that from my experience, when you're looking for the documentation and you have some sort of wiki-like Confluence in your company, and I would search for something like address, you would find a lot of results, but certainly not the documentation you're looking for. So that is a pretty handy feature if you're working outside of a bigger company.
Yeah. Martin, do you want to just show us quickly the Kafka Connect and the schema registry integration?
Yeah, sure. So schema registry, we only have 2 schemas registered here, and that's almost about it. Pretty simple. For Kafka Connect, we do support an arbitrary number of Kafka Connect clusters you can configure. So in this specific case, we have 2 Connect clusters configured, which one is a DataGen and the other one is Debezium. And you can manage all their connectors here. So what we're going to do now is to create a connector for one of these clusters. We will choose the DataGen cluster. And what just happened is after I selected that cluster, the Kowl backend would talk to the Connect cluster via HTTP and ask for all the available connector plugins. And that is a list that is generated by that. So we can see we have a DataGen connector here, which is created by our friends from Confluent. We will select that. And that connector is supposed to create some random data. And the cool thing about that form is that this is fully auto-generated. So based on what the connector reports, what configuration it supports, this form is generated. And also all the validation comes from the connector. So right now it says we have to specify a few topics here, which we will do now. So we want to produce to a topic called clickstream. Now it says that we have to configure one of these 3 fields. And the quick start field is a configuration which the connector asks for, and it is basically that we shall select a predefined profile which describes the data which we want to produce. And we will just select the clickstream, which was one of the supported values. And now we still have one issue here before we can proceed. It wants the connector name, which we will also call clickstream. And we can provide further properties like how we want to serialize the data. We will use the string converter for the key, and maybe JSON for the value. Okay, and that's already like the last step as part of the wizard, which is the review step, which would show you the JSON payload, which would be posted to the Connect cluster via HTTP. And you can also edit that payload if you want to. But that looks good to me, so I will finish that. And as you can see, it's already created. We are still waiting for the task to start up. Let me refresh that is. And if that task would fail to start up, we would also be able to see the error here, by the way.
That's awesome.
Okay. So what
can you go into the, after this, can you go into the, into like the topic introspection of the message that shows the decoding of like the output of the click stream being decoded and connecting to the schema registry and auto-discovering that? Because I think, to me, that was the piece. It's like, oh, look, you could deploy this connector. And by the way, if you want to see the messages, it'll do SSO and make sure that you're the right person to connect. And then once you're approved, what it'll do is that then it'll connect to the schema registry, which is also running in Redpanda, right? Because Redpanda is a single image. It'll decode the messages, decompress them, decode them, and then present it in a user-friendly format.
Okay, so for this specific case, we do not use the schema registry because I just chose the JSON converter, but we have another connector deployed which uses the schema registry. So it's just the default for the Connect cluster I've running. So we can also have a look at that topic.
I think that leads us to, we had a question around this, so this leads right in. But Andreas was saying, hey, can I filter on topics that have Avro prototype schemas? Do they integrate with the schema registry for that? So
yeah, you can. You can.
Right in line for that.
You absolutely can. So Avro is just interpreted as JSON, which is also true for the filtering engine. So we could also absolutely filter on a topic like this.
We need Andreas to drop emojis on the chat to see how excited he is, because it's just like hard to see. Like on a live audience, then you can see people's expressions, but on a Twitch stream, then emoji is the best game.
I hope that works, Andreas. And we have a question from Volden. I see that. We're going to get back to it, but it's about the future of Redpanda Kowl and all that stuff. I want to make sure we get to that. But yeah, any other things we want to see within Kowl itself? You want to show off there, Martin?
I think we could show the Kowl business version. What do you think, Alex?
You mean on the staging cluster?
Yeah, we have one deployed within our own staging environment.
Yeah, I think we should show maybe the SSO. I'm not sure that we could do introspection on a live Twitch stream.
Okay, let's do this. Okay, so with the extended version, there's single sign-on, which allows us to do authentication. Currently, we support GitHub, we support Google, and also Okta. And you can also use it all at the same time if you want to. Okay, so it does not only come with authentication, but also authorization, which makes it really cool. So you can see that little eye icon here, which would tell me what exact actions I'm allowed to do on that topic. So in this specific case, I'm allowed to run any actions except for deleting topic records. And every time I'm not allowed to do something, this is also visualized in the UI so that you're not just trying it and get some weird error or waiting for the response. It is just shown in the UI with a hint, hey, you do not have the permissions. So for instance, I'm not allowed to delete this topic here. And as you can see, I could delete this topic, but in this case, it is just grayed out and you get a tooltip for that. And all these authorizations will be done via a role-based access control. And you can define roles on your own with a set of permissions, and you can do the role binding by hooking it up to, for instance, Google Groups or Okta Groups or whatever you want. And that's pretty handy.
And then maybe the admin panel too.
Okay, sure. So let's say if you want to figure out why I have a certain permission, which I have not expected, or the other way around, why do I not have a certain permission? You can do that here. So as I said, I have two roles. One is the demo role, and the other is a viewer role. And on the right side, you can see why do I have the demo role assigned to me? And this is set here. So apparently we have a role binding which says someone with a Google user with that address gets assigned the demo role. And in this case, for the viewer role, we use Google Groups. And because I'm part of that Google group, I get assigned the viewer role. And that also supports, for instance, inherited groups. So if the engineering group consists of multiple team groups, it's also totally supported.
Awesome. Martin, not to cut you off, but we're coming up at the end. I think we have about 4 minutes left, and I do want to answer kind of the next set of questions. Alex, see if you want to just pull the
Yeah, sure. I mean, I want to pull in Volden. He's doing the great work for us here, and just saying, hey, looking forward to using this. Like, what are we thinking for upcoming features, integrations? Like, how do you we have this acquisition. How do you see this working with Redpanda going forward in terms of features and hosted versions, or what's that look like?
Yeah. So let's see. Here's what I can share. Kowl and expect some product updates on that, on the name and branding and all of that. But like besides the minor things, what I see it is now we get to co-design the future of streaming. So things that are missing, we have this, V8 WebAssembly transformation engines on like a effectively on a technical preview build, because we're collecting feedback from the community. It's like, how does the API feel? Does this do what I need? I think that's a long-term project for us, and it's something that we want to invest time, but we need to move like, does the community actually love the API? And so imagine Kowl really as a way to complement that part of the engine. And so for Apache Kafka users, it'll look like this, right? And the minute Kowl detects that it's actually talking to a Redpanda, it'll probably unlock new UIs and new capabilities. An example is we have this awesome tiered storage integration. And if you've missed it, we talked about the read path, the write path, why we built it. I think we spent maybe 3 hours on videos talking about the technical details, the like background, compaction, thread priority, CPU priority, our own S3 library, and so on. So check out those videos if you haven't seen them. But the point is, like, now that we have a way to give people interactivity about, real time, to a large extent, to me, there's many functions that Kowl does, but a big value to the people that are developing applications is this idea of time travel debugging. So let's say that you're storing 12 petabytes of data, but only 5 terabytes are stored in like your live cluster. Why couldn't you actually go and exit and introspect, petabyte 0 or petabyte 1, right? And like, obviously, it's going to talk to the Kafka API, blah, blah, blah. But the point is, like, how do we keep advancing the state of the art of streaming and making it easier? And if you look at the complexity curve, Redpanda is all about pushing the complexity curve all towards the center. It's like, why couldn't streaming be the default way of building applications? And so the umbrella way, or I guess the category of thinking about Kowl and the future for us is, how do we keep pushing that boundary towards the left to make streaming more accessible to more developers?
Absolutely. I love that. And like for me, just getting some of that visibility of like, what the heck is actually going on within my organization. We saw it with the Connect instances. We saw it with consumer groups, just getting a sense of that, but being able to see that with tiered storage, like you're saying, with WASM transforms, Redpanda transforms, getting a sense of that, maybe do some editing there. I think there's some really exciting stuff happening there. So be looking for that. And I just want to follow up. Andreas ended up, he was very happy about the answer with the integration and the auth as well. So some nice work. Yeah, we're running up on time. So Martin, thanks a ton for joining us, for walking through this demo. So excited to have you on the Redpanda team and be working on some of this stuff. Alex G, as always, thanks for being on here and telling the story, sharing the vision of what's going on with Redpanda and all that sort of thing. So yeah, great having both of you today.
Thanks, Alex. All right, Jetson. Bye, everyone. Great to be here.
Thank you.
Y'all, one last pitch I'm going to say, if you're going to be at Kafka Summit London, make sure you come visit the Redpanda team, because they'll be there in the flesh. So stop by the booth, talk to them, get a sense of how you're using Redpanda or questions you have, whether it's about Kowl, whether it's about Redpanda, different things like that. Make sure you reach out for them. Again, join the Slack community, tweet out at us, whatever it is. But otherwise, we'll see you next time on.
I heard, just to wrap this up, I heard that Redpanda is the cutest mascot in big data. So you'll get to pick up a sticker if you come to the Kafka Summit. And with that, thanks everyone.
Perfect.
Bye.
Thanks all.